students, our next topic is electrostatic potential and potential energy. Now if we consider a positive charge here, then this will generate electric field lines through this, and this we can say that a source energy. Now if we keep any charge here, so this with this positive Q charge, electrostatic force will generate, and to this, if we consider that this force is here and some electrostatic force is generated, then this will be Fe. Now this is point A, and if we consider point B here, then to move from point A to B, we have to do some work for this, and some force will be applied that we called as force external. So some external force will apply so that A will be B. Now, so the work done in bringing a charge from A to B, that is V A to B. Now, so we can say that UB minus UA will be equals to UA, that is the potential energy from in B and potential energy in A. So difference of potential energy VB UB minus UA will be equals to WAB. Now we know that the force external and force electrostatic force is in opposite direction. So we can write F external is equals to minus Fe. That is, the force external is equals to in the opposite direction of electrostatic force. Now work done is equals to A to B F external into dr. So work in the form of electrostatic force we can write minus of A to B Fe dr. Okay, so that is the electrostatic force which we are taken minus of integration A to B Fe dr. External force, when we are applying, work done is of A to B will be integration of A to B F external into dr. Now in this, what we have done, if we are considering a positive charge, so that due to this positive charge, electric force of lines or electric lines will generate. So this field is known as the source energy. Now if we are taking a positive charge in some distance, then due to this test charge, some electric force will generate. Now if we consider a point A and B, to bring a charge from A to B, we have to do some external work. So external work will be in this side towards the B. Now, so work done in bringing a charge from A to B will be equals to WAB. Okay. Now the potential energy present in B minus potential energy present in A. So the difference of potential energy will be equals to work done in bringing a charge from A to B. Now force external, when we are giving some external force to bring a charge from A to B, that is force external. Now due to this positive charge, some electrostatic force will generate, that is Fe, electrostatic force. Now this is in the opposite direction, so negative sign indicates that this is in the negative or opposite side. Now work done in bringing a charge from A to B will be equals to integration of A to B F external into dr. F external, that is this. Now in terms of electrostatic force, W is equals to integration of A to B Fe dr, and this will be in opposite direction, so minus we are considering. Now so if this point is in the infinity, so in infinity the potential potential will be 0. So U infinity will be 0 because in infinity the potential is 0. So at point P, the potential energy, we are considering point P here. So in potential point P and in potential infinity is equals to work done in bringing a charge from infinity to point P, then this will become 0. So UP is equals to work done in bringing a charge from. So we can say that the potential energy present in point P will be equals to work done in bringing a charge from infinity to that point. Okay. Now, the work done by electric field in moving a charge does not depend on the path. So, if we consider a closed path, now this is point A and this is point B. So, in bringing a charge from A to B, the work done by electric field in moving a charge does not depend on the path. So, to move the charge from here to here or here to here, we have 3 paths. So, 1, 2 and 3. So, the work done in bringing a charge from 1 to A to B will be equals to W1 is equals to W2 is equals to W3 because work done is equal whenever we are moving a charge from A to B. Now, electrostatic potential in per unit charge we are considering from infinity to P in per unit charge. So, in this the potential energy present, that is Vp is equals to Vp minus U infinity upon the potential energy present in bringing a charge from infinity to P. So, this will be equal to this, and we know that potential at infinity will be 0, then electrostatic potential will be equals to potential energy present at P upon Q. This is the electrostatic potential where electric potential or potential energy in per unit charge. Now, potential difference, that is del V is equals to Vp minus Va, and we can say that this will be equals to W AB upon Q, and which is equals to UB minus UA upon Q. So del V, that is electrostatic potential, will be equals to the difference of potential energy in per unit charge. Now our next topic is electrostatic potential due to a system of charge. Now if we considering a system of charge, that is considering a point P here, and with this we have system of charge or so many charge. So this will be Q1, Q2, Q3, Q4 with distance of R1, R2, R3, R4, and we know that potential will be equals to, electrostatic potential will be equals to 1 upon 4 pi epsilon 0 into Q upon R. So we will use the principle of superstition that V1 is equals to 1 upon 4 pi epsilon 0. We will calculate the potential in every point of Q1, Q2, Q3 and Q4 into Q1 upon R1. For potential 2, 1 is equals to 1 upon 4 pi epsilon 0 into Q2 upon R2. For potential V3, 1 upon 4 pi epsilon 0 into Q3 upon R3 and so on. So for calculating the potential in nth, 1 upon 4 pi epsilon 0 into Qn upon Rn. Now we will simply add this and we will get V is equals to V1 plus V2 plus V3 up to Vn. Now V is equals to 1 upon 4 pi epsilon 0 into Q1 upon R1 plus 1 upon 4 pi epsilon 0 into Q2 upon R2 and so on 1 upon 4 pi epsilon 0 into Qn upon Rn. Now we are finding the resultant potential. So V is equals to 1 upon 4 pi epsilon 0, that is common, and Q1 upon R1 plus Q2 upon R2 and up to Qn upon Rn. Now taking summation, so we can write V is equals to 1 upon 4 pi epsilon 0 summation, that is I is equals to 1 up to n Qi upon Ri. This is the system of charge. Okay. Our next topic is potential energy due to electric dipole in an electric field. Now potential energy due to dipole. Now if we are considering an electric field, in this if we consider a positive and negative charge, because in dipole we are considering there is an equal distance of an opposite direction. So in a dipole moment we are considering minus Q and positive Q charge. So the intensity in this will be the force applied on this, and the intensity will be on this side. The force present in plus Q and minus Q will be in opposite direction. Now this will be present in theta, the angular momentum will be this side. Now the torque to act on this on moving a charge. So if this will be a torque Q, then some external force will apply. So this will be torque external, because there will be a translatory motion. Because of opposite charges there will be no translatory motion. So torque will act and this will generate. Now due to this dipole moment, torque will be generated, and we know that torque is equals to P into E. Now opening this cross product, we get tau is equals to PE sin theta. Opening this cross product, we get tau is equals to PE sin theta. Now the work done by tau will be equals to tau is equals to P cross E. Now tau will be equals to PE sin theta. Now work done in these will be dW, which is equals to tau external into d theta. Now amount of work, we will calculate the amount of work done in moving a charge. So amount amount of work done will be equals to from 1 to 2 integration of theta 1 to theta 2, because this will move, so our theta will be changed from 1 to 2 will be tau external into d theta. Work done from 1 to 2 will be equals to theta 1 to theta 2 Pe sin theta d theta. On integrating, we get d12 will be equals to Pe minus cos theta theta 1 to theta 2. Now, this is the W12 will be equals to the potential energy stored in it, which is equals to minus of Pe cos theta 2 minus cos theta 1. Now, this work is stored as the potential energy of the system. So, potential present in U2 minus U1, which is equals to minus Pe cos theta 2 minus of Pe cos theta 1. Now, this will be theta 1 will be pi by 2, because if we are rotating this will become 90 degree. So, cos theta 1 will be pi by 2, where potential energy is taken as 0. Potential energy will be 0. Now, U theta 2 will be equals to minus Pe cos theta 2 minus cos theta 1. Or cos theta 1 we can write pi by 2. Now, U theta 2 will be equals to minus of Pe cos theta, because theta 2 taken as theta. Now, U theta will be equals to minus P into E, or U will be equals to minus of P into E. This is the potential energy due to an dipole in an electric field. Now, what we have done, we have considered two charges, that is negative Q and positive Q charge. Due to this, some electrostatic force will generate, or the force of positive Q will be this side and force of minus Q will be this side. They will generate a force between them, and electric dipole, the distance will be considered as 2a. In equal distance, two opposite charges will be present. So, intensity of this electric field is this side. Now, torque will be acting due to a translatory motion. Now, due to opposite force, there is a translatory motion. So, torque will be acting. So, if this side torque, that is tau, and some external force is applied, so this will be tau external. So, tau, we have considered that tau is equals to P into E. Now, tau is equals to Pe sin theta. Now, we are considering this, that work done in bringing a charge from 1 to 2, that is integration of theta 1 to theta 2 Pe sin theta. Now, integrating sin theta, we get minus of cos theta. Putting values, we get W12 is equals to del of U is equals to minus Pe cos theta 2 minus cos theta 1. Now, this will be equals to the difference of potential we are putting u potential for u2 minus u1, that is minus Pe cos theta minus of cos theta 1. Now for theta 1 we are considering pi by 2 because of the motion which are for tau external, the angle will turn into right angle, that is pi by 2. So pi and theta will be considered as theta 2 will be considered as theta, and the presence of potential energy will be 0. So u theta 2 is equals to minus of Pe cos theta 2 plus minus cos theta pi by 2, and cos theta pi by 2 will be 90 degree, cos 90 will be 0. Sorry, cos 90 will be 0. So u theta is equals to minus P into E, or u is equals to minus P cross E.